So, in the last couple of videos, we've been talking about rational equations and finding asymptotes, vertical, horizontal, oblique. Um, we haven't actually graphed anything yet, except for 1 over x. But before we look at another example and actually graph it from start to finish, there's one more thing that I would like to talk about, and that's multiplicity and vertical asymptotes. Okay, so multiplicity in a vertical asymptote is going to give us something that well, we can kind of use as a guide to figure out what our graph is going to look like. So we looked at the graph of 1 over x. Okay, and that did something like this. So we had a vertical asymptote along x equals 0. We also had a horizontal, but that really doesn't have anything to do with this part of our conversation. Um, and this graph did something like this. Right? Okay. So using what we know with our transformations and translations and such, if I were to negate the graph of 1 over x, put a negative sign out in front of it, I would expect these to flip sides. Okay, because everything that's negative is now positive and everything that's positive is now negative. So I would be looking at this graph. I still have my vertical asymptote. I still have my horizontal. Excuse me. But remember, this is about vertical asymptotes. And so now this graph does this. Okay, so everything flips there. Now, if I were to look at the graph of r of x equals 1 over x squared, well, any negative number I plug in for x is going to turn positive because of the square on here. So I still have a vertical asymptote. And I know they're hard to see, but if you can't tell what I'm doing, I'm drawing a dotted line. So x equals 0 is my vertical. We still have y equals 0 as a horizontal, but this conversation is about vertical asymptotes. So 1 over x squared, if everything that is negative that I plug in for x turns positive, this graph is going to look something like this. Okay. And once again, finally, let me scoot up just a little bit. If I'm looking at r of x equals negative 1 over x squared, I would expect this to flip upside down. And indeed it does. So still have my asymptotes. And this graph would look like this. Okay. So how does this relate to multiplicity? So here, my highest exponent here is 1. That's an odd number. Here, my highest exponent is 1. It's an odd number. So for an odd multiplicity, the graph approaches opposite infinities so infinity on one side of the vertical asymptote and negative infinity, excuse me, on the other side. Okay, so that's what's happening here. Along my vertical asymptote, in one direction, I'm heading up towards infinity, and on the other side of my asymptote, I'm heading down towards negative infinity. Okay, same thing here. Even though I negated it, I'm still heading up in one direction towards infinity, and I'm heading down on the other side of my vertical asymptote towards negative infinity. Okay. So for the next two, I have my highest exponent as 2. So these are even multiplicities. Okay. So the graph approaches the same infinity on both sides of the vertical asymptote. Okay, so and that's what's happening here. They're both heading up towards positive infinity, and in this graph, they're both heading down towards negative infinity. Okay, so for even multiplicities, they're going to head in the same direction, both up or both down. For odd multiplicities, they're going to go in opposite directions along the vertical asymptote. Okay. So let's try to put this all together, and let's start the process of pulling information from an equation in order to graph it. So let's say we have r of x is equal to x squared minus 4 over x squared plus 3x minus 4. Okay. So our end goal is to graph this, but the first thing that we want to do whenever we see a rational equation is to factor it. Okay. So here I have the difference of squares in the numerator, and here I have something quadratic that is factorable in the denominator, so I'm just going to go ahead and start with all of my factoring. So the numerator factors into x plus 2, x minus 2. And in the denominator, I'm looking for the factors of negative 4 that are going to add up to give me positive 3. So I'm looking at x plus 4, x minus 1. Okay. Well, this is fully factored, but nothing is going to cancel out here in numerator and denominator, so it's also in lowest terms. Okay, so my domain here, remember my domain is before reducing. I don't have to reduce here, but it still needs to happen before you reduce. So here, I have x such that x cannot equal negative 4, and x cannot equal positive 1. So setting both of these equal to 0 is where these two numbers are coming from. Okay. Also, since nothing reduced, we can say that there are no holes. Okay. Function is already in its lowest terms. So now we can look for our vertical asymptotes. So vertical asymptotes. Okay. Remember, my vertical asymptotes come from the denominator when it's in its lowest terms, and we have our denominator in its lowest terms here. So my vertical asymptotes happen around x plus 4 equals 0 and x minus 1 equals 0. So here x equals negative 4 and x equals positive 1. Okay, so this is my answer because it is a special line. It's a vertical line. So x equals negative 4 and x equals 1. Okay, so it is still different from my domain restrictions. Now, horizontal asymptotes. My horizontal asymptotes, and I know it's going to be horizontal because the lead term here, my exponents are the same. So in the numerator, my lead term is x squared. The denominator is also x squared. So we are in the situation where n equals m, and that was the coefficient of the numerator divided by the coefficient of the denominator. So 1 divided by 1, that just equals 1. So y equals 1 is my horizontal asymptote. Okay. I want to specify that it's y equals 1 because it is a horizontal line. This is the equation of that line. Okay. Now, something else that we want to look at when we're graphing, remember that our graph will never cross a vertical asymptote, but it can cross a horizontal or an oblique asymptote. And since I know I have a horizontal asymptote, I want to know if my graph is going to cross it. And I found my horizontal asymptote, it's a special line, and in order to find where this graph is crossing, I'm going to take my function and I'm going to set it equal to 1. So let's do that. So crosses the horizontal asymptote. I have x squared minus 4 times x squared plus 3x minus 4 equals 1. Now, this looks like it's about to be really messy to try to solve, but remember that I can put my denominator in parentheses, and then I just need to multiply by my denominator on both sides. So times x squared plus 3x minus 4 times x squared plus 3x minus 4. Happens on both sides, okay? Sorry, I didn't know it was going to be that hard to see in red. But this will cancel out my denominator. And now I'm left with x squared minus 4 equals x squared plus 3x minus 4. Okay, so I want to continue solving for x. That's going to end up giving me a point of where my horizontal asymptote is being crossed. I already have my y coordinate. Solving for x is going to give me the x coordinate of that crossing. Okay. So I want to set this equal to 0. So I'm going to subtract x squared from both sides. I'm going to add 4 to both sides. Okay. The left-hand side cancels out. Everything adds up to 0. On the right-hand side, too, my x squares are canceling out, and so are my 4s. So I'm left with 0 equals 3x. For my own benefit, I'm going to switch that and say 3x equals 0. Then I would divide both sides by 3, and I'm left with x equals 0. So my graph crosses my horizontal asymptote at the point 0, 1. Okay. Incidentally, this is also my y-intercept. That doesn't always happen. Since I'm graphing, I would probably want to find a y-intercept just so I can know what's happening at that point. Plugging in 0 for x is not difficult. You'll get a solution here. Okay. So I found a y-intercept. I found where my graph crosses my horizontal asymptote. I found my horizontal asymptote. I found both of my vertical asymptotes. We've expressed our domain already. We know there are no holes. One of the last things that we want to do before we start graphing is our x-intercepts. Okay, so remember my function r of x was x plus 2, x minus 2, x plus 4, x minus 1. I want to use the fully factored version of my equation to find my x-intercepts because I need this to be factored because I'm going to take both of these terms and set them equal to 0. Okay, having my denominator set equal to 0 is where the holes and the asymptotes came from, the vertical asymptotes. But setting the numerators equal to 0 is going to make the entire expression 0, so those are going to be my x-intercepts. Okay, so x plus 2 equals 0, x equals negative 2, x minus 2 equals 0, x equals positive 2. Okay, so let's kind of start trying to sketch this out. This x has a multiplicity of 1. The x-intercepts have multiplicity 1. So they're going to cross the x-axes. My denominators also have a multiplicity of 1, so after I'm starting to graph, I know that we're going to go to opposite infinities on either side of each of these asymptotes. So let's make this 0. Say 1 is right here. So I know there is a horizontal asymptote along the line y equals 1. I'm going to draw a dashed line to represent that. And I know I have vertical asymptotes at x equals negative 4. So I'm going to use a dashed line there to represent that. And I'm also going to have a vertical asymptote at x equals 1. Okay, we found the y-intercept, which is also where we're crossing our horizontal asymptote to be 0, 1. And I also have x-intercepts at negative 2 and positive 2. Okay, so now we want to pick test points. And we're going to pick about 4 of them. And we really just want to see what's going on this side of this asymptote, on this side of this asymptote, and then on this side of this asymptote. Okay, so we're going to pick a value here. And then we're going to pick a value way over here, just to see what's going on. Okay. So let's pick negative 5. On this side of this asymptote, let's pick negative 3. On this side of this asymptote, let's pick 3/2, so 1.5. Okay, so that's going to tell us what's happening right here. And then I'm going to pick 5. Okay. So I'm just going to go back to my original function and evaluate. So f of negative 5. For me personally, I'm going to use this equation because it's faster. That's how I work this out. So I have negative 5 squared minus 4 all over negative 5 squared plus 3 times negative 5 minus 4. Okay, so in the numerator, I end up with 25 minus 4. And 25 minus 15 minus 4 in the denominator. That gives me 21 over 6. So that's approximately 3.5. Okay, so it's positive. So that means over here, I am well above the asymptote. So I'm way over here. Okay, so my graph is going to do something like this. Now I also picked f of negative 3. So that's negative 3 squared minus 4 divided by negative 3 squared plus 3 times negative 3 minus 4 gives me 9 minus 4 all over 9 minus 4. That gives me 5 over negative 4. So negative 5/4. So this one was positive, this one is negative. So that means here at -3, I'm below my x-axis. Okay, so I'm traveling down here. I know I'm going to cross this x-intercept. I know I'm going to cross right here. So if I'm crossing here, I'm going to end up going to positive infinity along the second vertical asymptote. Okay. So I'm doing something like this. Okay. And then I picked 3/2. I already have the idea that if I'm approaching this positive infinity, this 3/2 should mean I'm approaching negative infinity. Remember, each of these had a multiplicity of 1. And that was a non-multiplicity, so just like it happened over here, I'm going up towards positive infinity on one side and down towards negative infinity on the other. The same thing should be happening over here. So I'm expecting a negative number right here. So f of 3/2. Okay. That's 3/2 squared minus 4, all divided by 3/2 squared plus 3 times 3/2 minus 4. That gives me 9/4 minus 4 over 9/4 plus 9/2 minus 4. So here I have -7 over 4 divided by 11 over 4. So that is -7 over 11. It's negative. I'm going to use quotation marks right here so we can see it. So that means I'm way down here at 3/2. I know I'm going to cross this. So I'm looking, when I select 5, I'm looking to be traveling along this horizontal asymptote, because that's what horizontal asymptotes do. They tell us the end behavior. So I'm expecting to get something smaller than 1, but positive. So let me scoot up here. Sorry, this is going to be a touch small. F of 5, that is 5 squared minus 4 divided by 5 squared plus 3 times 5 minus 4. So that gives me 25 minus 4 in the numerator, 25 plus 15 minus 4 in the denominator, so 21 over 36. That is approximately 0.5833. So this here is also positive. It is also smaller than 1. Okay, so here our graph is doing this.